Hello everyone, welcome to another Fuelin Q&A. Today we are joined by Dr. Bill Harris, and we couldn't be happier. It's going to be an enlightening talk and hopefully cover some of the myths and other controversies surrounding omega-3s, omega-6s and omega index. We will get started because there's a lot of information for us to get through today. We're going to obviously introduce Bill. We're going to talk about omega-3s, omega-6, the omega index. We're also going to look at what the current research findings are, and then hopefully we'll certainly give you a lot of practical takeaways and then discuss a potential challenge. Who are we? We are Fuelin. Elizabeth Infant is a performance nutrition coach. Dr. Alan McCubbin is a registered sports dietitian based at Monash University. And my name is Scott Tyndall. I'm a registered performance nutrition coach as well, and one of the co-founders of Fuelin, which is the only training-based nutrition app in the world that syncs directly with your training plan. We're going to get into the meat and potatoes. So I will just introduce Dr. Harris and let him just introduce himself with his esteemed biography, I think is the best way to put it. Bill.
Yeah, well, that's great, Scott. Thanks a lot for reaching out to us and giving me a chance to talk about my favorite topic. By way of background, I have a PhD in nutrition, and I did a postdoctoral work in, actually it's in my postdoctoral work in Portland, Oregon, that I got first introduced to omega-3 fatty acids in the late 1970s. And my boss actually assigned me to do a study to see what the effects of about a cup a day of salmon oil, just drinking a cup a day of salmon oil would do to people's lipid levels. And so that was my first introduction to fish oil studies. And we published that in 1980. So it's been 23 years, I guess, since we've been in this field, or 43, excuse me. I've been on the medical school faculty at 3 schools, currently in South Dakota, where I'm living. And I was 20 years ago with a colleague named Clemens von Schacke. We developed the omega-3 index blood test based on the idea that omega-3 levels in the blood are as much as cholesterol is a risk factor. I know that's controversial, but everybody knows what I mean by cholesterol being a risk factor for heart disease. We believe that the omega-3 index was equally, if not more powerful risk factor, and that there needed to be a test available for clinicians, for researchers, for consumers, that they could test their omega-3 levels and titrate it to a healthy level. So that was about 20 years ago, and started Omega Quant Analytics as a laboratory. I left the university and started my own company, and we offered this test now and a variety of other tests around the world to people who want to just track their nutritional status. And so it's been a fun run, and we continue to do research and publish on omega-3 and health.
Perfect, Bill. Thank you. I think it's always very worthwhile just for people to understand sort of, especially a presenter like yourself, your expertise, so that there is some credibility behind what we're discussing today.
Yeah.
So I think, look, what we discussed before this was let's get into omega-3s and 6s and considerations for everyday people and certainly athletes. And the focus primarily today for the talk is on health rather than performance metrics, and we may get into the performance metrics on a subsequent call depending on the appetite of everyone, excuse the pun. We discussed, let's try and keep this as high level whilst not dumbing down everything too much, but let's talk about omega-3s and specifically, what are they?
Yeah. I always like to first of all explain, well, they're fatty acids. So what's a fatty acid? A fatty acid is a chemical. It's a long single chain of carbon atoms hooked together. And most carbon atoms in that chain are hooked together with what we call single bonds, if you remember any of your chemistry. And occasionally there's a double bond in that long chain of fatty acids. If there are double bonds, we say the fatty acid is unsaturated. If there are no double bonds, we say it's saturated. The omega part of omega-3 comes from, it's not just kind of science fiction-y cool, which it is, but it's not the reason for it, it's because in chemistry, we name the different carbons in the carbon chain with different Greek letters. And the first carbon is always the alpha carbon. And the last carbon, whatever carbon number it is, the last one is always the omega carbon because of the Greek letter alpha, the Greek alphabet alpha and omega. And if you count back 3 positions from the omega carbon, you get your first double bond in all the omega -3 fatty acids. And you count back 6 positions to the first bond, you double bond, you get your omega-6 fatty acids. So that's really the sort of the last name, if you will, of each family. Depends. It's that last portion of the long fatty acid chain. There's also an acid group on it, which is where it gets the fatty acid name. So those are the omega-3s, omega-6, that's nomenclature. What are they? The ones we care about particularly are EPA and DHA. Those are, EPA is a fatty acid that's got 20 carbons in it and 5 double bonds. And DHA is 22 carbons and 6 double bonds. Well, so what? Most fatty acids have 1 or 2 double bonds. So having 5 and 6 really makes these things unique, very flexible. Fish oil is actually the only animal oil that doesn't freeze. Well, you can always freeze it eventually, but doesn't freeze in a refrigerator like lard or tallow would be from an animal. So fish oil is a liquid animal oil, and partly because these double bonds make it very difficult to freeze it. The EPA and DHA, then there's the plant omega-3, symbolized, well, it's not symbolized right here, but it's the typical plant omega-3 is alpha-linolenic acid, and it's found in things like soybean oil. Soybean oil is where we get most of the alpha-linolenic acid in our diets. Traditionally, unless you're going out of your way to get ALA, then you would take flaxseed oil or chia seed oil. There's a little bit in things like black walnuts, but fundamentally, soybean oil is about 7% ALA, and we eat quite a bit of soybean oil. So that's where we get it.
Bill, just on that, just so the athletes know, because they will have seen ALA quite a lot and they may not know what that actually represented. So, and you mentioned there that ALA can be found in soybean oil. Is that correct?
Yeah.
So, and I think maybe a common misconception there is that soybean oil could be bad for you, yet it does contain ALA. So could you just explain that a little bit more? Because ALA is typically, most people will focus on things like chia seeds,
Right,
and sesame seeds and things like that. But you mentioned there soybean oil as a potential source for ALA, yet we, as we've heard in recent social media posts, and even just the other day, I saw a whole lot of controversy about a recent post about an article about oils or polyunsaturated oils and seed oils in particular being bad for the health. Can we just explain that a little bit more?
Oh, yeah. Exactly. So ALA, alpha
Within a few minutes.
within a few minutes, right? Yeah, exactly. Well, yeah, soybean oil is like 50% omega-6 fatty acid, roughly. Linoleic acid, the omega-6, the primary omega-6 in our diet. And again, about 7% of the fatty acids in soybean oil are ALA. So it's it's not a rich source of ALA, like flaxseed oil is 55% ALA. So there's a huge amount in there.
What's the other 37%?
Oh, it's omega-6, linoleic acid, some palmitic acid, some just a variety of other fairly simple fatty acids.
Okay.
So do you want to get into the seed oil thing? I don't.
Oh yeah, look, I think it's worth talking about it.
Okay.
Because I think like we're going to cover obviously animal and plant omega versus 6 versus 3. But let's go into it now. I think it's worth talking about.
I think we got to talk about the omega-6, omega-3 controversy, and then there's the seed oil controversy, which is a slightly different thing, because even though seed oils do provide most of the omega-6 in our diet, that doesn't mean, even if there's something raunchy about seed oils, and I'm not saying there is, but even if there is, it doesn't mean it has to be the omega-6 contained therein. because the studies we've done, and there have been several down that have looked at this, we measured blood levels of omega-6 fatty acids in thousands of people. And then we followed these people for years and years and see who develops what diseases. And if a high level of omega-6 in the blood, linoleic acid particularly, because that's the primary omega-6 in the blood, if a high level of that was harmful, you would think you would see the people with the highest levels developing chronic diseases, heart disease, diabetes more rapidly than people who had low levels. But it's exactly the reverse. What we've seen and we've published is that the people who have the highest omega-6 levels are the ones that are the least likely over years to develop cardiovascular disease or diabetes. So that to me says there's something good about having higher omega-6 levels than having low levels. It doesn't necessarily address the seed oil controversy, whatever it is. The omega-6s are good. There may be other things that are bad in seed oil. I'm not saying there isn't. I'm just saying the omega-6s are not the problem. We should really not make an effort to lower omega-6. The problem in America, the problem in most of the Western world, is the lack of the long chain omega-3s. It's not the presence of the omega-6s.
And I was going to touch on that, Bill. So omega-6s, potentially higher levels of the linoleic acid are okay, but is that in relation to the levels of omega-3 as a ratio?
Yeah, well, I'll get on a soapbox about a ratio too.
Yeah. No, and we'll show what the ratio looks like and how you present that in a minute.
Yeah, because we'll talk about the omega-3 index, which is just EPA and DHA. That's all it is. It's as opposed to some people who like this omega-6 omega-3 ratio in blood or in food or whatever metric they're talking about. The problem I have with it, number one, it presumes omega-6 is bad, and that's wrong. Number two, you can have a ratio of 10, say, and you could be eating a high amount of omega-3 and a high amount of omega-6, and you'll have a ratio of 10, or you can be eating almost no omega-3 or no omega-6, and you'll have a ratio of 10. So the ratio is not informative about when you have to talk about absolute amounts, and that's a problem. And there's a million ways to change ratios. You can raise the omega-3s, you can lower the omega-6s. Some of those choices are good, some of them are not. The other problem is it's not specific about which omega-3s are in that ratio and which omega-6 fatty acids. There's 7 omega-6 fatty acids, there's at least 4 omega-3s. And it just piles all of them together, assumes they're all the same thing, and which is not true. So it's a very imprecise, not very informative metric. So other than that, it's just fine.
And would you look at that ratio, therefore, in relation to your omega index?
No.
And then look at the individual levels of the omega-3s and omega-6s?
Well, one certainly can. I mean, I think there actually is a case for making a blood test. We've developed a blood test for omega-3, EPA, DHA, higher is better. I would love to make because I think the evidence is strong, a linoleic acid index and promote a higher level people. I think we'd get a huge amount of blowback for that, based on what I consider the ignorance about the omega-6 story. But I'm not sure I want to invite controversy at this point.
Would that linoleic acid ratio or index be, you said there was multiple, what did you say, 6 different types of omega-6?
Right. So I wouldn't just use omega-6. I just use linoleic acid.
Just linoleic. Okay, fine. So if we go back to omega-3s then, so animal sources of omega-3s?
Standard sources are, I think you've got a slide on it. We'll talk about it in a minute. The smash fish, we'll go over what the smash fish are. Typically high oil, what we think of as highly oily, not like cod, not tilapia, not shrimp. Those are seafoods that have hardly any omega-3 in their flesh. Cod, of course, is well known for having a lot of omega-3 in its liver, but it does not store it in the flesh like salmon, mackerel, herring, etc. do. So those are the good sources of EPA and DHA. We'll talk about probably the algal sources of EPA and DHA. It's not like you can just go buy seaweed and eat seaweed and get omega-3.
Is seaweed a good source though?
No.
Okay.
No.
And then from a plant perspective, you mentioned algae. So
algae,
that is a potential and it's new on the market.
There's plenty of it on the market, and it's not algae per se that's on the market. What's on the market is a EPA or DHA derived from algal oils, and the algae are single-celled organisms. These are the microalgae, they're called, and there's thousands of different species in the ocean naturally, and scientists have discovered some species of microalgae make EPA and some make DHA. So you can isolate those species and grow them up in big vats and feed them sugar and sunlight and water, and they'll make omega-3s. And then you can, and that's actually the base of the food chain where the fish get their omega-3s, is in the from eating ultimately the algae produced omega-3s.
And it's a viable source for
it's a viable source.
Vegetarian or a vegan athlete who wants to avoid eating animals. Okay.
Right.
And then you mentioned other sources of omega-3 from plants.
Well, there's not much yet. There's a lot of research being done, and with good success of if we can get over the GMO phobia and accept the fact that if you insert certain genes into, like soybeans, for example, you can get the soybean to make EPA or DHA. And then you can grow a plant that produces EPA and DHA on the ground. Anywhere you have dirt, you can grow it. And we would not have to harvest fish or microalgae anymore. We could get all of our omega-3 from, but it would be a genetically modified soybean oil that would produce EPA and DHA.
Has that been done yet?
Yeah.
It has.
And
just
camelina,
the fear of germ.
Yeah, there's that's another topic.
Okay. And then you mentioned ALA as a source.
ALA?
Yes.
Yeah, it's definitely an omega-3. It's not one that will raise your omega-3 index, because EPA, you can make a little bit of EPA from taking a lot of ALA.
And how much are we talking in terms of ALA? Like, because vegetarians, vegans will tend to rely on ALA as a source of omega-3, but is it actually a viable source to increase EPA and DHA levels?
No. It doesn't change DHA at all, and it maybe raises EPA, 0.25%. You can detect it. Actually, DHA levels go down a little bit when you increase ALA intake. So the net effect on EPA plus DHA is pretty neutral.
Okay. And so that's quite interesting and quite important for either strict vegetarians or certainly vegans to consider, and potentially have, say, their omega index tested to actually look at how their levels sit if they are not consuming a source of EPA, DHA. Would that be correct?
That's correct. And the vegans that we've analyzed are some of the lowest. I mean, they're tied. In the study we did in vegans, their omega-3 index was something like 3.5, and that 3.5%, which we'll get into in a minute, which is low.
Yeah.
The only other group that we've measured that tied that was U.S. military servicemen and women deployed in Iraq. They had exactly the same crappy omega-3 index, which is terrible.
And that, which would have been, I presume, due to dietary restriction at the time?
Right. They were not vegans.
Okay.
That's for
sure.
But
just not getting fed.
They're just eating military rations without any fish, right?
Okay. Fair enough. A case for maybe addition of omega-3 supplement to military food. Yeah. That's another story as well.
That's not
in terms of omega-6s, you touched on what they are. Animal sources of omega-6s?
Yeah. Kind of the parallel or the cousin to EPA in on the animal world, on the omega-6 world, is arachidonic acid, what we call AA or ARA. It's a 20 carbon, 4 double bond omega-6 fatty acid. And it's probably the most, well, I can't say it's the most important, second most important omega-6 in the body. It's obtained from diet. It's made by animals. It's not made by plants. And it is it's produced from linoleic acid, and it is the precursor or the starting material for hundreds of different bioactive molecules. If you've heard prostaglandins, leukotrienes, resolvins, protectins, a variety of these very bioactive molecules are made from arachidonic acid. Some are pro-inflammatory, some are anti-inflammatory. It's a very complex web.
And that would give another reason why necessarily PUFAs or polyunsaturated fatty acids aren't necessarily bad for the human body to consume, if I'm hearing you correctly. Is that correct?
That's correct. That's correct.
Okay.
And yeah, I just reject the idea that you can label an entire family of fatty acids as pro-inflammatory, which is absolutely not true. The omega-6s.
And we've discussed this previously as well, where, you know, if we give the analogy of exercise is pro-inflammatory. Yeah, that inflammatory process is actually important and good for the body. And I think it's that lack of understanding where how looking at something in isolation and looking at its causal effect and not looking at the bigger picture sometimes can lead people down that rabbit hole of, oh, that's bad for you.
That's right. That's right. Yeah.
Okay, so let's talk about the omega index. What is it? I know you touched on that you created it, but what is it exactly?
Yeah, actually, the official name is the omega-3 index.
Sorry, omega-3.
It's okay. You know, a lot of people just call it the omega index. That's fine. What is it? It's a measure of how much EPA and DHA is in the membranes of your red blood cells that circulate in your blood. And we intentionally picked a red blood cell or a cell membrane to measure the omega-3s in, because that's where they do all their work, is in membranes, not just in red blood cells, but in all the cells of the body. So if we get a picture of how much EPA and DHA are in a red cell membrane, we can imply or infer that it's similarly related to other tissues. We express it as a percent. So it's EPA plus DHA as a percent of the total fatty acids in a membrane. And every membrane's got, well, we don't know how many, I don't know how many fatty acids, but I know that omega-3s are typically between, say, 3% and 10 or 12% of the total fatty acids. So that's sort of the range of the omega-3 index. Like under 4% is, we think, bad. 8% and above, 8 to 12% is what we think is a sweet spot for having, that's the best omega-3 index value.
And that number of 8%, I've seen that, and I often mention that to athletes. That's sort of the benchmark. Where does that 8% come from?
It came from our 2004 paper when we first proposed the omega-3 index as a risk factor, when Dr. Von Schacke and I published that. And we looked at the literature that was available pretty much up till the year 2000 and looked at the blood levels, basically the red blood cell omega-3 levels in a variety of studies where they'd been reported. And we found the number, the value in every study that was associated with the best cardiovascular health. And we just took an average of all the numbers we could find, and it came out to be 8%. So.
And was that related? That was related specifically to cardiovascular disease rather than metabolic disease. Has there been follow-up studies in relation, because omega-3s are often discussed in relation to, say, metabolic disease, say type 2 diabetes, or even neurodegenerative diseases? Has there been follow-up studies looking at? I mean,
it's holding up. I think it's a number miraculously that's holding up, whether you look at dementia, you look at total mortality from anything. Cancer, other causes, not only cardiovascular. It's holding up in, I'm thinking mostly cardiovascular. The areas of diabetes, we've seen in a big cohort study, the highest levels of omega-3 associated with the lowest risk of diabetes, and it's roughly 8%. So it's a good target, and we know it's safe, and it's achievable. You don't have to take supplements to get there.
Yep. And so you talked about the measurement being in the red blood cell is one way that omega index can be measured. Can it be measured via other methods?
Well, commonly measure it in a dried blood spot.
Mhm.
And if you think about it for a minute, a dried blood spot is 50%, roughly 50% serum and 50% red cells. That's about the ratio of red blood cells. And there's a lot of fatty acids in the plasma too. So when we're doing a percent of total, we're really getting a percent of EPA and DHA in the whole blood, which is a little bit different number. It's a different percentage. Actually, in red cells, the level's higher than in whole blood. So we calculate what the red blood cell equivalent is when we do a dried blood spot assay. So that's how we get the omega-3 index from a dried blood spot. There are assays out there, and there are labs offering plasma omega-3 EPA tests, EPA DHA tests. And we don't think that's the best, but I'd rather have that than nothing. If people want to use that to track their omega-3 status, it's a little noisier metric. It flips and flops, goes up and down day in, day out, depending on what you're eating. Whereas the red blood cell doesn't. If your viewers, I'm sure they are familiar with the difference between plasma glucose levels and the hemoglobin A1C as markers of glycemic status, diabetes status. The hemoglobin A1C is measured in red blood cells, and it's a much more stable long-term reflection of the way your blood sugar levels has changed. Plasma levels are like this. It's the same thing with plasma omega-3 and red cell omega-3.
Yeah, we talk about the HbA1c, and obviously it doesn't give you those day-to-day fluctuations, which I know some people will say are super important, and that's, again, another topic. But I think looking at that stability over time and looking at what your number is probably the most important thing, where we talk about trends over time. And
right.
So I think in that respect, so that's the way that it would be measured. In terms of, you said there was some flexibility or flux between that measurement day to day via, what did you say, whole blood, plasma, when they're doing it that way? Is
you just measure in plasma, right?
Yeah.
Plasma levels vary more with day to day within person.
Is the day to day variance, is that significant though? Like if it goes up 1%, 2% in terms of that index, is that a significant shift? Like where do we sit with what is a significant shift in the index, or what do you consider a significant shift?
So again, I mentioned that being in that 8 to 12% is the sweet spot. Most Americans are in the 5.5.
I think you're being generous. Everything I've seen has been well below 5. So,
oh well, I mean that's when we do big population studies, and when you got 150,000 people, take an average, and that's what it is. It's around 5.5. But so going from 5.5 to 7 would be a big step forward. That's a big step down, improvement in risk. Just because you're not at 8 doesn't mean you're at 5 or 4. Every 1% increase is a great step forward. We just think the sweet spot, the best place to be, the place you want to hold it, is between 8 and 12.
8 and 12. And in terms of measurement, you mentioned a dry blood spot. Athletes have the ability just to, and we'll talk about this right at the end, but they can just actually click on Omega Quant and order a test kit. That's correct. And it just gets sent to their house, and it's a simple pinprick test. It hurts as much as doing a standard pinprick on your finger. You put it, having done it multiple times and done it with many sporting teams. It's very simple. It's very quick. And, I think the results, and again, what I'll show in the next slide is what it would look like for an athlete, how it's reported. But I mean, from my perspective, super easy and very easy to, I think it's one of those markers I love with an athlete because it's so actionable. You see
exactly.
You see this percentage and you go, look, we can change this. And again, I mean, I'll ask you about, like, is there any downside in having higher omega-3 index? And my understanding is there is a little bit of controversy about a higher index in relation to atrial fibrillation. Is that correct?
Well, yeah, I mean, that's
but the percentages, again, like, let's talk statistics. What does that relative increase look like?
Well, it's just so this fairly small increase in risk for atrial fibrillation showed up in the last two studies, two pharmaceutical dosing studies. So 4 grams a day of EPA DHA. So that's
which is very high.
Which, yeah, I mean, it's not toxic by any means, but
No, but it is high.
that is the indicated dose for the omega-3 drugs.
Yeah.
And that's approved by the FDA, et cetera. And so in this last study, out of 8,000 people over 5 years, I think the incidence of new onset atrial fibrillation was 2% in the placebo group, and it was 3% in the omega-3 group. So that's where you can play with statistics. You got an absolute increase of 1, or the increase was a 50% increase. You know, you can look at it either way. But right, that's, you know, the trouble is what's disconcerting is that you can get an increased risk for AFib, but the primary concern with AFib medically is increased risk of stroke, because if the blood pools in your upper chambers in your atria, they can form a clot, and the clot can go to your head and stroke. So in the same studies where they found a small increase in AFib, they found a significant decrease in risk for stroke. So, hello, you know, is it an adverse effect or not? It's just the first thing that's ever popped up that had anything adverse effect about omega-3. So people are paying a lot of attention to it, but it's a very, very small effect with a very high dose.
But as you say, it was a percentage change from 2% to 3%, which, you know, yes, as a percentage could be regarded as significant, but actually when you look at it in absolute terms, it's still very, very low. So
Right.
And if that's the worst thing, I mean, I think there's a lot more benefit from what I'm seeing.
Quick question on the AFib. Was that for people that hadn't yet developed AFib and then did, or was that for people that had AFib and their risk for further symptoms went up?
It's the former. No
Okay.
AFib at baseline.
Is there a danger for people that do have AFib?
I think there were so few people in that study that actually had AFib, history of AFib.
Okay. And Scott, we might cover this, but since we're talking about the testing, how soon, since athletes will be doing this, and I've done mine, the test is very easy. Can you see an improvement? Like, how long does it take to make that?
Yeah, good question. I mean, if let's say you're low or normal, and then you want to bump it up. So you do a test, you find out you're 5%. You want to get up to 8%. First of all, on our website, the Omega Quant website, there is a calculator, omega-3 index calculator, that you can put in your current number and then set, I want to be to 8%. How much omega-3 should I take? And it'll give you something usually between 1,000 and 1,500 milligrams a day is what it takes. But it takes about 3 to 4 months before you're going to be in a new steady state. So because the red blood cells, it takes a while for them to turn over. Every 4 months, you get a whole new crop of red cells. And it takes, so that's why really the 3 to 4 months to get a new steady state.
Perfect. Thank you.
We did, when we did this at the Maple Leaf, so Bill, I think we did test sooner than 12 weeks, and we still saw some significant improvement as well. So we definitely can see improvement with it, but I think to your point, if we do this competition, it will be around the 12-week mark, just to really try and control the controllable. So
right, and you want to be
you want to stay significant. Exactly.
You want to get your stable level again.
Exactly.
You want to still be going up.
So I've got here, I've just taken a few little screenshots. This isn't actually a report. I took some screenshots from my own report. Not to show that my index is very good, but also to show that it actually increased significantly. So when I first had this tested, I think I sat at around just under 6%. I didn't consume omega-3 supplementation very often. I certainly didn't consume sardines, pickled herring, and other delicious oily fish on a regular basis. So I certainly made it my goal to improve this, knowing that I'd had a history of concussions through rugby, and being very aware of my brain, and a little bit scared, to be honest. So what I did see within 3 months was a huge jump, and I've managed to maintain that at somewhere between 11 and actually I did get up to 14% at one time, and I backed off in terms of supplementation because I thought it was just a bit high. But what I love, and I think we were talking about before, is that it is one of those blood tests you can actually change, a bit like vitamin D. I think in that respect, there seems to be a direct causation impact on the index and things like your omega-6/3 ratio, your arachidonic acid and EPA levels, related to supplementation and eating of these oily fish, and seeing that direct impact. Now, the other really interesting thing that I haven't put here is it did have an impact on my lipids as well. Now, again, that may be a correlation, and you know, there's plenty of things I do in my health with exercise and everything else, but you know, it was fascinating tracking over time, looking at HDL and LDL levels and seeing, you know, a slight bump in HDL and a slight drop in LDL over time. Now, was it related to the omega index? Was it related to that? Not sure, but certainly I saw that. The other thing that I know has popped up in the research is, and you can talk about this in terms of autonomic nervous system impact, but I have an extremely low heart rate now. And I do put it down to, I saw a drop with that with supplementation of omega-3s. Do you want to just touch on that in terms of how omega-3s could impact that?
Yeah, that's true. It was observed many years ago that people with higher omega-3 levels, or people in randomized trials that were given omega-3, had a maybe 2-3 beat per minute drop in heart rate, presumably by some activation of the parasympathetic or suppression of the sympathetic nervous system. We think that's part of why there's a reduced risk for ventricular fibrillations, which is the kind that kill you. And it may actually help explain some of why there's a little increase in AFib in some people if your heart rate goes down. But it's a known effect. It's a good effect to a point, obviously. And it may help explain why actually people live longer if they have higher omega-3s, saving a few heartbeats for keep you going a few more.
I certainly think if I'm saving a few, I'm saving a few for later in life. So
for later in life when you're really needing it.
Bill, I pulled this quote from a podcast you did on the Sigma Nutrition with Danny, and I thought it was brilliant. But you know, and I think it's something for athletes and everyone, not just an athlete, to think about. That, you know, and I'll just read it directly, that we should be viewing omega-3s as a lifelong nutrient, not just something to be given at the end of life from -9 months of age all the way through. And, you know, do you want to just you can briefly discuss what you were referring to there?
Well, I'm probably referring to the medicalization, the pharmacologicalization of omega-3 fatty acids, where it's been tested in many of the fairly recent clinical trials haven't shown a benefit. Some of them have, but there's been a spate of trials that haven't shown any benefit of giving omega-3 when they started, you know, in people who are age 65, who are already on a plethora of other drugs, who've already got cardiovascular disease, and they give a low dose and they give it for 3 or 4 years, and they expect the omega-3s to change everything. Funny you should pull that up. And in arguing against that stupid design, that's not the way you test a nutrient. You test a nutrient, and nutrients to be taken your whole life. And again, the -9 months is simply because the omega-3s are important in brain development for the baby and for mom as well as she's pregnant. So that comment more is a reaction to the people that want to dismiss omega-3s because they don't work in these some of these randomized trials.
Yeah, and I think that's a really good segue into these trials. And look, we're not going to go into extreme depth with these studies. I think we can touch on each of them and just talk about, you know, if we talk about, do you pronounce it the GISI? Is that how you say it?
Yeah,
GISI trial.
It's an acronym. It's an Italian research group. Sure. Yeah.
So let's talk about that. That was back, what, how many years ago?
It's published around 2000.
2000, so 20 plus years ago. And it was a fairly low dose of EPA, DHA,
right,
or vitamin E, a decent amount, lowish, moderate, or a combination of both.
Right.
And the placebo, sorry, I did remove that. A placebo was nil. It wasn't
Yeah.
vegetable oil.
It was just, you're right, usual care.
It was just usual care. Everyone got the same care. What did that trial show?
That trial showed a remarkable benefit of the omega-3s in reducing risk for sudden death, for total mortality, for cardiovascular events. It was a knock it out of the park home run study that really put the omega-3s on the map. It was the first really big randomized trial with omega-3. It was done in patients with who had survived a heart attack. So they're all known cardiovascular disease patients. It was really just about the time statins were starting to ramp up. At the beginning of the study, only 4% of people were on statins. By the end of the study, 50% of people were on statins. But by and large, there was no statin in the background. And I think it was very successvul.
Yeah, but it was done in people who had suffered a heart attack, and then effectively those who took the EPA. The vitamin E had no impact, is my understanding.
Right, no change.
And the EPA, DHA supplement, a fairly low dose, actually had a significant impact on them 20 plus years ago. We fast forward to the Reduce It trial, which was what year? Just remind me.
That was about 2018.
2018. So about 5 years ago. And we saw a very high dose of just the singular EPA.
Right.
At 4,000 milligrams per day, which was a pharmaceutical intervention, correct?
Right.
And that was against what they thought was a placebo in mineral oil. And a fairly large subset, 8,000 people, singular endpoints. The singular endpoints were
multiple. I mean, they had a composite also, but every endpoint they looked at that had to do with cardiovascular disease was reduced, including basically including total mortality, at least in the U.S. cohort. It was an international study. The GISI study was just done in Italy.
Okay.
Yeah.
And one of the controversies with the Reduce It trial was the placebo, wasn't it? That it potentially
remains a big controversy. Just 2 weeks ago, another paper came out questioning the idea that this trial might not, the success of this trial, the difference in outcomes between the placebo group and the active group may have been caused by the placebo group increasing risk for cardiovascular events, not so much that the active group had a reduced risk of events. So it's unclear to what extent the adverse effects of mineral oil taken for 4 years at 4 grams a day, just a lot. That appears to have contributed to the apparent benefit of EPA in this trial.
Do you think they will reproduce that trial with perhaps a vegetable oil or a true placebo? It would be wonderful if they did.
The trouble is there's no financial incentive right now.
Yeah. Okay.
The government.
And then the Vital trial, which was a combination, very similar, I guess, the dosage to the GISI trial. Mm-hmm. A fairly large cohort, 26,000 participants. What did it show?
And this was a primary prevention study. So people in this were men over 50, women over 55 with no history of heart disease or cancer. And the primary question was, and vitamin D was the other arm. It's kind of like the GISI trial. It had 4 arms, omega-3, vitamin D, the combination, and neither. And they found that when they looked at what they call their composite endpoint, which again is a mixture of a variety of different cardiovascular outcomes, totally death from a heart attack, having a heart attack but surviving it, having angina, having a stent put in, having a stroke, fatal stroke, non-fatal stroke, all that, put that into one pot and say, if any of those things happen, then you had the event. And they do it to bump the numbers up because it's cheaper. Studies aren't so long. In any event, the composite endpoint did not find a benefit. And so that's what they report in their abstract. And because that's their pre-specified primary endpoint. And if it's not affected, then they say it doesn't work. until you look at the details. And I know you have, Scott, and I have, and there are several outcomes. For example, total number of heart attacks was significantly reduced by 30% in the omega-3 group in that group. And that's lost in the composite endpoint. You can't see it.
And that's how it was reported in, say, the New York Times.
Oh, everywhere, right.
That it showed that it had no significant outcome and that omega-3s weren't worth taking, yet it didn't actually look at those singular endpoints, which were significant.
And again, here we're talking about 4 or 5 years in people who are on average 65 years old. Okay, so fine, it doesn't work there. I get it, but that's not the question. The question is, do they work if you take them for 50 years, right? And
also the dosage there was fairly low.
Fairly low, yeah.
Fairly low. And I guess something I've heard you talk about is that everyone's awareness of omega-3s is perhaps a little bit better these days, but also the consumption of potentially statins may, and other medications may convolute the picture a little bit and maybe make it look less favorable than what it is. But that's still a benefit if they are taking them and reducing heart attacks in combination. But I guess if you could avoid having to have the statins by maybe looking after your health in the first place, that might be a good place to start rather than relying on that.
Yes. Yeah.
Which leads us into this. So I think this is another great quote that I've heard you say, which is, you can't put all your eggs in a randomized controlled trial bucket. You can't decide if omega-3s are good for your health at large over your whole life from a trial done at the end of your life for a lot of people who are already at high risk. They are not irrelevant, yet they need to be looked at in context. And I love this because I know, and we talk about randomized control studies a lot. It's a very important source of truth.
Yeah.
But I think, and again, I listened to Peter Attia talking about this the other day, and we discussed this, that you can't solely rely on randomized control studies as your sole source of proof. Like, yes, we are evidence informed. We're not, you can't say you're always evidence based, because there is a deal of there's a lot of observational studies that still carry, or prospective studies that carry a lot of weight. And I think a really good example of this, I put in the chat group, the parachute study, which I think is a fantastic study. And we laughed about this. And this was a study done. Oh, do you want to explain the study?
Well, yeah. We were talking about this last night. We were chatting. 2003, British Medical Journal. A couple of people got so tired of being harassed for using therapies or treatments that had only been shown in observational studies to be helpful and had not been shown in randomized trials. So these two folks from Cambridge got whacked off, and they decided, okay, let's see, how about parachutes? Has anybody ever done a randomized trial on parachutes? We all think they work, but there's no evidence for it, and by the way, people die in parachute accidents, and there are people who have fallen out of airplanes and not died. So what's your evidence that, it's a 2-page thing, and it's tongue in cheek and it's fun. And it ends with all those, he says something like, those people who would advocate for only using evidence-based medicine should volunteer for a randomized placebo-controlled trial of parachutes.
Exactly. And their trial was effectively because they couldn't find the number of participants who would agree to jump out of a plane at 4,000 feet without a parachute. They had to manipulate the study so that they jumped out of a plane with a parachute or without a parachute whilst the plane was on the ground. And funnily enough, those who had the parachutes or those who didn't have the parachutes had the same outcome, but it was in relation to the study design and also the participants. So I think it is important, and I know it's tongue in cheek, but it is really important for people when they bang on about RCTs being the only source of truth. You've got to look at what the actual study was and who the participants were in that study as well, and what the intervention was, because that can have a significant impact on the results.
Absolutely.
And I think that's such an important point. Hopefully that wasn't lost on everyone. We talked about SMASH, and I think this is a lovely acronym for everyone to remember. Certainly, most Fuelin athletes will get sick of me either sharing photos or videos of my anchovies, herring, or sardines on toast. But I love the acronym for SMASH. It's so simple. I know that Omega Quant provides a lovely detailed list of these types of fish and their relevant amounts of EPA and DHA in the report, which I think is fantastic. And for me, yeah, I think pickled herring, I love the Swedes and the Nordic countries anyway, and that's where I was introduced to pickled herring in the first place. But I think pickled herring is one of the greatest types of breakfast foods that you can eat with scrambled eggs. I do love it. I think anchovies on toast, fantastic, like such a great filling meal, but also just packed full of protein and these quality omega-3s. And then, you know, cans of sardines, if you're in a pickle traveling, you know, picking up a can of sardines for, you know, $1 or $2 or whatever it is, and getting a good quality amount of protein and omega-3s is so simple and yet so beneficial for so many people. And it's often that, oh, my grandma used to eat those, I don't really want to eat them, and people will turn their nose up at it. But I think if you eat quality sources of these particular 5 fish, you really can enjoy it. And I think it's, I challenge athletes and challenge people to try and consume one source of fish per day, and they're like, what? But it's like you're eating either 4 or 5 meals a day. Certainly, you know, the consumption of one source of fish per day is not out of reach, and I think it's certainly something worthwhile doing. And as I said, from a practical standpoint, I've seen the benefits of it.
Yeah, it's great.
So we talk about supplements a lot, and you know, you mentioned you don't necessarily think you have to consume a supplement in order to get your omega index up. If someone was at, say, you know, let's say 3 to 6% on the omega index, would you advocate supplementation to potentially, I like the way we talk about supplementation is it should complement your diet. So I like referring to supplements as complements rather than supplements.
Okay, good.
And if you wanted to try and get it up quickly, like it's a bit like vitamin D, isn't it? You could go and try and sit in the sun and get it up. Or if you're deficient or insufficient, you could take a dose, a higher dose for a certain period of time, get retested, look at your levels and go, okay, now I'm in a good spot. What does that look like from a food perspective now that I'm in a good spot? Would you advocate complementing your diet with supplements to boost that level as quickly as possible, say in that 12-week period?
Sure. Yeah, I have no problem with taking supplements. I mean, I take them for years.
Yeah. Okay, that's good.
Yeah.
And look, and I think it is we often use that term food first, yet not food only. And I think it's very relevant, because even when you test the omega-3 content in some of these different foods or different fish, the content varies from fish to fish, even in the same species. And I think that's been shown. So in terms of providing reliable sources of omega-3s on a daily basis, certainly if you are insufficient or deficient on that omega index, I think it makes sense, certainly to me, and I think to Elizabeth and the rest of the team, to complement that diet with a known amount of omega-3s. And I put up this as a label for people to look at, because I think what I often see is I'll get sent the front label of a supplement, which will often say high strength, high potency omega-3, and it will have 1,000 milligrams on the front of the label. You flip it around, you look at the supplement facts or the NIP, the nutritional information panel, and then the EPA DH content will say 150 milligrams and 200 milligrams or something like that. And when you look at this label, what do you see as the key elements for you to focus on?
First thing I look at is the serving size. And in this particular one, it's an oil, it's a liquid. So they're talking about 5 milliliters, which would be 5 capsules of a standard encapsulated oil. And so that just to figure out what we're talking about here. Sometimes they'll say 2 capsules, sometimes they'll say 3 capsules. So you got to be aware of what the serving size is. And then I look down to EPA and DHA, how much per serving. And this is great. This has got about 2,500 milligrams in a teaspoon, which is great. You take several pills to get that, which is the advantage of a liquid. So that's what I'd look at: EPA and DHA per serving, and what's a serving.
Yeah, perfect. And I think just for everyone listening, that just flip your bottle around, look at the EPA, DHA numbers, And certainly, as Bill said, look at the serving size. If serving size is 3 capsules and it's only giving you 500 milligrams total of EPA DHA, you may be better off thinking about taking a different supplement, because if it's 500 milligrams and there's 3 capsules and you're looking at taking 3,000 milligrams a day, you're going to be taking a lot of capsules. You're going to be taking 18 capsules a day. And you might laugh at that, but I had that exact conversation with an athlete 2 days ago. And they were horrified. And I said, you might be better off throwing them out. And lo and behold, they did.
So can you go back to that, Scott? I want to press on a couple of things. So does it matter on the ingredients list if it's anchovies and sardines, if it's salmon and mackerel, if it's krill, if it's whatever, like, how do you know, or how would the athletes know that it's a quality source?
Any of those are going to be quality sources. Very rarely is, well, I mean, if you're going to use salmon oil, it's labeled salmon oil, but by and large, they don't use salmon for these things. Salmon actually, as a percent of total, the omega-3s are not that high unless you concentrate it. So anyway, krill oil is the one you mentioned. And of course, it'll be all over the front of the package that it's krill oil. You won't have to wonder where that came from. And krill oil is a fine product. It's phospholipid based. It's at one time people were screaming about huge improved absorption from phospholipids in krill. That's all kind of gone quiet now because the evidence has now come in. It's not, it's good. It's absorbed well. It's not like ethyl esters, which are absorbed rather poorly. But you would see here in the ingredients if it was an ethyl ester too. They should tell you, but they're not saying that here. So it's a triglyceride. Yeah. If it doesn't say phospholipid, it doesn't say ethyl ester, it's a triglyceride.
Okay, and I probably should have had Scott pick like a non-quality supplement so we could see, are there common fillers or maybe potential, like this one has no gluten, milk derivatives, artificial, yada yada, like are there red flags when you see a fish oil supplement that you will automatically?
Yeah, I mean, one thing that they sometimes do, sometimes you see these total omega supplements. They got omega 369, which is ridiculous. There's no reason to take 6 and 9. We eat plenty of omega 6. We can make omega 9s in your body out of sugar. I mean, you don't need to eat it. So those are a waste. I think if it's just an omega 3 supplement, sometimes you look on the back and a lot of the omega 3 is ALA.
Ah, yes.
And you don't see any EPA DHA, or you see a little bit of EPA DHA and mostly ALA, So those are things to look out for, I guess.
I think the other thing that we didn't mention actually, Ian, something you can often see on the label where it's been screened for heavy metals. Mm-hmm. And that's something I think that's worth looking at, that it has been screened for heavy metals and that it's free from.
Yeah, and that's typically one thing you won't find in a supplement is a heavy metal, because the efforts they go to all the steps in refining these oils so that they are to get rid of the bad tastes, for lack of a better word. There's a lot of distillation steps to clean it up and to make it clear, and all that gets rid of any mercury. Mercury really stays with the liquid part of the aqueous part of the fish. It sticks to the proteins. It doesn't stick. It's not water soluble. So you're not going to get mercury. If you're concerned about anything, it would be a lipid soluble thing like PCBs, dioxins, things like that.
And the PCBs are often because that's something that's talked about with consumption of, say, farm fish, and that's again, I think you can often see that on the label with a fish oil where it's been screened for the PCBs.
Yeah, right.
And while we're on the heavy metals, just because I think people might ask, if we're encouraging them to eat more fish, are they worried now about higher heavy metal toxin consumption? Like in this case, would supplements be safer potentially?
Well, if you're going to get all your fish from shark and swordfish and king mackerel, those are high mercury fish, but the smash fish are not. Okay. There's very little mercury. They're small fish.
Just wanted to point that out to people because I have
Okay. Right.
I always get pushback and they're like, but the mercury, and I'm going, I'm not, don't fight me on this. Trust me.
Yeah, the mercury story is a whole other, I mean, that has been so overblown.
Yeah.
But anyway.
Thank you.
So I think when we sort of wrap this up, I think it's, well, firstly, Bill, thank you. You know, I always learn a lot talking, discussing this with you. I think for athletes and anyone listening to this, I think it's, you know, have a think about, do you actually know what your omega index is or what your omega status is? And maybe also flip that and go, what is your current disease risk profile? Like, do you have a family history of heart disease? Do you have a family history of metabolic disease, neurodegenerative diseases? And then if you sort of match that up and you were to understand what your omega index was and is it potentially low, could you actually do something to that, either through your daily habitual nutrition or through a combination of supplementation and improving that nutrition sort of on a daily basis? And I think the only way you're going to know that is probably testing it and having a look at it. And as I said, it is, I believe, certainly a worthwhile test to get done, as it is very actionable. It's not one of those tests where you sort of get it done and go, oh, what do I do now? You can actually change it. And I think in that, much like we talk about any testing, you get a baseline, you hopefully apply an intervention, and then you look at a secondary measure to look at the outcome. And so I think in terms of that, what we discussed and what we'll probably throw out to the team at another time, and certainly I'll throw it out on the Facebook group to a wider group, and look at, maybe we can do some sort of competition. I think it would be fantastic to, you know, look at getting, you know, the 700 plus Fuelin athletes to do this and really look at, can we make a significant change to it? But I think getting a baseline measurement, you know, taking somewhere, you know, around that 3,000 milligrams EPA DHA per day, looking at that 12-week timeline, and then we assess, look at the biggest change in actual number, but also maybe a percentage change as well, because, you know, it's tough sometimes going from, if you've got a high number already and you significantly, you still improve that percentage. I think it's important looking at the percentage as well. And maybe throwing out something like, you know, a month of premium coaching. Maybe we can look at, you know, some supplementation for a few months and things like that. We're going to refine the details of this, but we will throw it out to the group and see if there is an interest in it. And I would certainly love to see, I think, from the perspective of potentially improving, you know, some younger people's lives before, as we get to that end of life. You know, if you haven't started supplementing or taking your omega-3 seriously, then there's no better time than now. So we'll keep you posted on that and let everyone know. And then I put out, just from a Omega Quant perspective, these are some links if you want to follow on Twitter or LinkedIn, Facebook and Instagram. Just look for either at Omega-3 Index or Omega Quant or Omega Quant Analytics, and you'll be able to find that. So, Bill, thank you so much. I know there was a question from someone who actually has dropped off, but he asked about spirulina as a source of DHA and EPA. Do you have any comments on that?
You asked about what?
Spirulina.
Spirulina. I'm not aware that there's any omega-3 in spirulina.
Okay. Right.
He's
but
I don't think so.
He's a vegan athlete. So
yeah.
There
sure
isn't, and it's not a high source of protein, as spirulina tries to convince vegan.
Well, it's probably high in relationship to its actual total body weight, but then in terms of actual
but anyone that's tried to take
protein,
more than like a teaspoon of spirulina will know, like, it is dreadful.
yeah, exactly. So does anyone have any other questions? Those that are still on the call, does anyone have any questions?
I think Marguerite had one I saw in the chat. It said, how much EPA DHA algae source should vegans take? But we answered that. So, and equal amounts. The 3,000, shoot for 3,000 a day.
That'll do it.
Yeah, and just on that, Margaret, we did use an algae based supplement when I was at the Maple Leafs. It's called Brain Armor, and we did see significant changes. We used it mainly because we had, we had to account for all the dietary preferences, and we sort of had to account for vegans. So we said, oh, well, bugger it. We'll just take an algae supply because the omnivores and everyone else could eat that, but the vegans could as well. So, and we did see a significant bump. However, we were taking 2 pouches a day, and I believe that supplement alone is about $3 a day per serve. So we were taking $6 a day, which is fine when you're with an NHL team with a fairly limitless budget, but for the average person, $6 a day in one supplement is a lot. So yeah, if you're not a vegan-based athlete, I'm not sure what the pricing on that is now. If you're not a vegan-based athlete, there's certainly far more economical supplementation options out there, is what I would say.
Like sardines.
Like sardines, exactly. So, well, it depends what sardines you're eating, Bill. I've been eating Ortiz lately, and they're about $11 a packet. So you can certainly get cheaper ones. But, look, thank you so much. I think hopefully everyone got a lot out of this, and we will be posting it to YouTube as well, and then we'll probably take some excerpts from it and use those in social media as well. So
great. Well, fun to do it. Enjoyed it.
Thank you so much for your time. Yeah, wonderful chat, and explained a lot, I think, to a lot of individuals.
Good. Hope it was helpful.
Thank you.
Take care.
Thank you so
Thanks,
much.
mate. Bye-bye. Thanks, everyone.